right, students, let's see what we can do on Module 2. I thought maybe a walkthrough for these things would help you with your notes. So here we go. I'm looking at 2-1 dividing rational numbers, the instruction piece. And there's a recipe on his phone or iPad, whatever that thing is. And it says he's having a party and he wants to have 42 servings of his favorite candy treat on hand to serve all the guests that he's invited. If he makes one batch, will he have enough to serve his guests? In this lesson, you'll follow Andrew as he multiplies and divides rational numbers to evaluate expressions. Your objectives are to be able to say, I can use the properties of operations to multiply rational numbers, and I can use the properties of operations to divide rational numbers. So now we arrow to the right, and we get to properties of multiplication. This is where your notes come in. So if I was a student, I would write down those properties right there. I would also write down this. And while I'm doing this, I'm going to keep moving, but you can pause the video to write those things down. So I'm going to continue on. Don't try to write while I'm talking. Pause the video and write it down if you want now, or you can pause it when we get done reading and write it down later. Anyway, it says Andrew needs to review the properties of multiplication before he can put them into use in evaluating division expressions. It says the commutative property of multiplication can be used to change the order of the numbers being multiplied together, and I've spoken about that in our meetings. The associative property of multiplication can be used to change the grouping of numbers being multiplied together. Taking a look at an example of how Andrew can use these properties to make his mental calculation easier. So here he's got negative 8.5 times 5 times negative 4. And he's using a calculator, so he multiplied negative 8.5 times 5 and got negative 42.5. And now he's multiplying by negative 4, and he gets 170. That's order of operations. That's not any properties being used except for just order of operations. Then over here, it says he's using the commutative property because he swapped or he moved the negative 4. He did that so he would get a whole number or an integer of 34 when he multiplied times negative 8.5. And then he can easily multiply that in his head, I guess, or using a calculator. Associative property here, what he did, it doesn't show where he grouped the the positive 5 and negative 4, but he grouped those last two numbers together, multiplied them, and then multiplied times negative 8.5. So that's how you can use those properties, and I don't know how to move these things. So I'm sorry, they're going to be in the way. I won't do that anymore. Anyway, it looks like Andrew added an extra step by reversing I was trying to see if I could find something okay, so it's magic. I made it disappear. I just paused the video and erased it. Anyway, it says it looks like Andrew added an extra step by reversing the order of operations and using the commutative property. Why would he do that? Since he isn't using a calculator, it's much easier for him to multiply those two to get 34 first. He also knows that every rational number has a multiplicative inverse. There's another thing you might want to write down, multiplicative inverse. A reciprocal of a rational number. The product of a number and its multiplicative inverse is 1. So if I have 1/2, the multiplicative inverse of that, when I multiply by it, should give me an answer of 1. And the reciprocal just means flip that over. So 1/2 and 2/1 are multiplicative inverses. You just flip them over. If you have an integer like 4, remember that 4 could be put over 1, and its multiplicative inverse is, you guessed it, 1/4. Okay, so that's what multiplicative inverses are. And I would write that down, and maybe even these examples, and you might also write down what the reciprocal is. Okay, so let me get my cursor back. Example of a reciprocal of 8. The reciprocal of 8 is 1/8. We can multiply 8 by 1/8 to get 1. And there's an example. Imagine a pizza being divided into 8 slices. Each slice is 1/8 of the original pizza. Another way to think about it is that it takes 8 slices that are 1/8 each to make one whole pizza. Okay, so there's your reciprocals. So if you need to pause the video and write that stuff down, now would be a good time to do it. Okay, the final property Andrew needs to review is the distributive property. The distributive property is when you, sorry, had to erase all that stuff. The distributive property is when you give something out to everything else. That's the easiest way. If I said, please distribute these, I'm asking you to hand them out to the group. So here is the definition for distributive property. I'm not going to use the marker anymore. Anyway, there's your distributive property definition. The product of a number and a group of numbers is the same as the sum of the individual products. So, for example, here's an example of how he could use these properties to simplify this expression. So he's got these two things in a group, and I don't really know why they changed that to 40ths. Oh, he's getting ready to add them together. I'm sorry. So he was getting a common denominator so he could add those together, and then he can multiply the numbers the way you're used to. But the distributive property says that I could multiply the -3/4 outside times each of the people, I call them the people on the bus. So -3/4 times 3/8 and -3/4 times 4/5. Then he can multiply those, and then you can see if you can reduce them at all, but you can also get a common denominator so that you can add them together. And that's what he ended up with, was -141 over -160. Usually you're not going to be using distributive property with fractions, but for this example, I guess they felt like it was necessary. I will use the marker. I'll show you what normally you will see distributive property with. Like if you have 2 times x plus 4, you can say 2 times x, which is just 2x, plus 2 times 4, and that would just give you 2x. Sorry, 2x plus 8. That's usually when you see it being used, is when you have a number times an algebraic expression. An algebraic expression means it's got a variable in it. Mathematical expressions just have numbers. Algebraic expressions have variables. That's a good 2 words for you to maybe write down. Algebraic expression and mathematical expressions. They are expressions because they don't have equal signs in them. Once you put an equal something, it becomes an equation. So, all right, moving on. All right, we're done with this slide. So now we arrow to the right. I'm going to pause. Okay, so Using different methods to solve. Andrew has a different cookie recipe that makes 28 cookies. He plans to have 21 guests at the party, and he wants each guest to have plenty of cookies. If he triples the recipe, how many cookies would each guest receive? Well, method 1, since each recipe makes 28 cookies, tripling the recipe would give him 28 times 3, which is 84 cookies. Then he could divide the total number of cookies by the number of guests, and it said he was going to have 21 guests. So if he divides that by 21, he gets 4. So each person could have 4 cookies. This is making me hungry. This process can be modeled by the expression 28 times 3 divided by 21. And then also this means the same exact thing. Okay? This is because the fraction bar represents division. That is another grouping symbol, like parentheses you can use to group. You can also use a fraction bar to group if you're going to end up dividing the answer by a number. Another way he could perform the computation without a calculator is to group terms together strategically. In other words, he could do this. 3 over 20. I don't know why he would do that, but how does it help? Well, let's see. Even though this might look a little more complicated, the fractions, 3/21 can be first simplified to 1/7. So I probably would have written it like I would have had 28 over 1 times 3. Actually, no, I wouldn't. I don't know. Anyway, what they're doing is cross simplifying. Right here, you see the 28 and 7, they could cancel each other out. And anyway, it does make it easier, but I think it's harder. Well, you could have done it right here. You could have said 3 and 21 are both divisible by 3. It goes in there once, and it goes into 21/7. So then you just got 28 divided by 7. So we'll do some of those in the Google Meet. I'll show you how to do that. All right, so now we're going to the next slide. Oops, sorry. And properties of multiplication and division. Andrew still needs to figure out how many 1/8 cup servings of Peanutty Crispity Crunch bars he will have from the recipe that yields 3.5 cups. To do this, he will need to divide 3.5 cups by 1/8 because he's going to make 1/8 cup servings. So he's taking the big batch and dividing it into little batches. So that tells you the operation you're going to use. So he could divide 3.5 by 1/8. Okay. Now, there are a couple ways you can do this. Actually, not really. The way you're going to do it is you're going to use step 1. Anybody want to guess? Hopefully you said fix it so that they are improper fractions. And they didn't. They said it will take 8 servings at 1/8 cup each to make 1 whole cup. So dividing 3.5 cups by 1/8 is the same as multiplying 3.5 cups by 8. This is the multiplicative property at work. So they just went ahead and they changed this to multiplying by the reciprocal. I usually wait and do that on the last step, but whatever. You can do it first, I guess. But if that was a mixed number back there, the second number, you want to wait because you got to flip the whole improper fraction if it ends up being a mixed number. So they went ahead and flipped it. Now I bet they're going to change it so that it's split that to make calculations simple. I think what they're going to do is use distributive property. So they're getting ready to, I bet you, go 8 times 3 is 24, and half of 8 is 4, so it's going to be 28. The other way you could do it was to change that into an improper fraction, being 3 times 2 is 6 plus 1 would be 7 halves times 8. And then you could say that would be 56 divided by 2, which I don't know. Let's see if it works. So they did use the commutative property to change the order of the numbers. And then they used the distributive property to perform calculations. And yes, it would end up being 28 also. Okay? So we'd have 28 servings that are 1/8 cup each. This would give you that also, because if you multiplied 7 times 8, that would give you 56. Divided by 2 is, guess what? 28. Okay? All right, so now we're going to the next screen. Practice. Andrew needs 42 servings for his party. So if he makes 1/8 cup servings, he will not have enough. What size serving should he make so that he will have enough servings for his party? 42 servings. I don't remember the problem. I'm sorry. Okay, there was his original 3.5 cups, and he wants to divide it into 42. That's what you needed, was that 3.5 cups. So what I should have done is I should have said, I forgot what he was doing. So he needs 42 servings of those crispity crunchy bars, and I should have went back here and I should have looked and saw, okay, so it makes 3.5 cups total, and he would need to divide that up into 42 equal portions. So again, I said the word divided, so we would take 3.5 divided by 42, and look what they did. This is an example that I would copy down. 3.5 divided by 42 is the original problem. They changed it up front to multiplying by the reciprocal, so that'd be times 1/42. And I really don't see that what they're showing you here is the best process for doing it. Okay, we'll see. So they've got 1/42 times 3, which gives you 3/42, and then they've got 1/42 times 1/2, which gives you 1/84, and then you've got to add those with a common denominator, so they multiplied this by 2 to get it to be 6/84, so you got to multiply top and bottom. Okay, and then they added together and got 7/84, and both of those are divisible by 7, giving you 1/12. So to serve 42 people, he would need to break that batch up into 1/12 cup portions. And I don't know where there's any 1/12 of a cup measuring cup. I've never seen one. I would probably just split it in half, and then split it in half, and then split it in half until I ended up with enough. But anyway, so let's go to the next slide. Lesson objectives. Now that you've completed this lesson, you should be able to say, I can use the properties of operations to multiply rational numbers. I can use the properties of operations to divide rational numbers. You should know your vocabulary, multiplicative inverse, and reciprocal. You should also know those properties that we talked about, commutative, associative, and distributive. And they're down here, along with the multiplicative inverse property. They've also got about every rational number has them. These are good things to write down. Okay. They also have a lesson review guide that, I don't know, it kind of puts it all on one page. I know that it says print. You can print it, but I'm going to tell you what's better for you is writing it, because writing it, something about you writing it out and thinking about it while you're writing it makes it more clear in your head. Okay. So we're done with our assignment. If we go to the right, does that do anything? Yeah, it takes us into the next topic, and we don't want that. So we need to go out and do our dividing rationals practice. Yours probably doesn't look like this. And yours probably doesn't look like this, or maybe it does. There it is. So there are your problems to do. You can use a calculator, but if you're going to use a calculator, remember to use Desmos.com. You need to be writing them down, though, the way they look on your paper, and you need to be using the scientific calculator. The only thing I want you to be using the calculator for on these is to do the actual computations. So you figure out the sign of this answer first. And I think that I gave you the opportunity to, what do you call it? Eliminate an answer. Okay. So I think if you want to eliminate answers, you can. If you can't, let me know, and I will look into it. But when you're working this, if you have to go somewhere, make sure you save and exit, because if you just close it, it submits it. Okay? So if you have to walk away to go have dinner or whatever, make sure you click save and exit, and then that way you should be able to come back to it. Now, I want to show you guys, I don't know how you're accessing your lessons. You should be going to your landing page. Well, that's not the landing page. Let me get to it. Okay, you should be coming here. And I know there's on yours, there's a blue bar here, and it says activities and to-do list. Don't use the to-do list. That to-do list is misleading to you guys. What you should be doing is opening this folder and then working straight down through the assignments. The other thing I'm going to tell you is, as you're working through these assignments, things happen in the background. Like if you've taken something and you've been given a retry, it may have a little swirl over here, but you really should go back to the instructional piece before you do the retry to refresh your memory. So when the things are listed twice, like dividing rational numbers is there for you twice, the first one is the instruction. Okay? So hopefully this helped. I'll try to do a few more of these in just a few minutes, but I do have tutoring this afternoon at 3. So, and by the way, I am recording this on 10/8 Thursday. So if you're thinking, oh, she's tutoring today, no, probably not. All right. Peace.